We are so lucky to be able to solve equations with square roots today. It is amazing. All right, over here on the left-hand side, you're going to notice that there is just a square root. And whenever we see just a square root, we can get rid of that square root by squaring that side because we know the square and the square root are inverses, so they're going to actually cancel out. But we also know that if we do one thing to one side, we're going to have to do it to the other side. So I'm going to go ahead and take that. The square and the square root will cancel, and then we're going to rewrite that statement as x plus 3 equals to x minus 3 squared. And now you're wondering, well, where do we take this? Okay, some people would say, well, let's go ahead and multiply x minus 3 squared. Somebody might say, let's take the square root. What we are going to do is the first one, we're going to pull this off to the side, and we're going to take x minus 3 squared, which means x minus 3 times x minus 3, and we're going to use our area model on that. So let's go ahead and multiply that up. So I'm going to take x minus 3, and then I'm going to multiply that. So x times x is x squared, negative 3 times x is negative 3x, negative 3 times x is negative 3x, and negative 3 times negative 3 is 9. We'll pull that out of the area model by saying x squared, negative 3x plus negative 3x is negative 6x, and then plus 9. Now, once we have this product of x minus 3 times x minus 3, we're going to bring that back into the equation, and we're going to rewrite this step. So let's do that. I'm going to write x plus 3 equals to x squared minus 6x plus 9. Okay, and you're going to notice, hopefully you notice at least, that we have a quadratic. So there it is. There's that squared that tells us that it's a quadratic. Well, what do we need to do to solve a quadratic? We need to set it equal to 0. So I need to get one side equal to 0. So I need it to say 0 equals to the quadratic. So how are we going to do that? We're going to get rid of that x plus 3. And in order to do that, we're going to get rid of the positive x with a minus x, and we're going to line it up underneath that same linear term. I'm going to get rid of that positive 3 with a minus 3, and I'm going to put it under that constant over there. And from there, we can just go ahead and collect our terms. So over here, this makes the 0 that we were looking for. And I'm going to have x squared. Negative 6x minus 1x would be negative 7x. And then 9 minus 3 is going to bring us to 6, positive 6. Now, at this point, based off of what we know, is how do we get from here to solve for x? Why do we get from that quadratic that said equal to 0 to solve for x? Well, we bring it off to the side, and we are going to use the area model again. But this time, instead of multiplying it out, we are actually going to factor that. So let's go ahead and bring those pieces into our area model. So x squared, 6, and then we know at the diagonal, we need that negative 7x, and we need these two pieces to add to negative 7x. So we can make our list. You should be able to do this pretty quickly. 1 and 6 can multiply to get that 6. We need 2 and 3 could also multiply to get that 6. But remember, we need them to get to that negative 7. So the only way I could do that is if I had a 1 and a 6, and if both of them were in fact negative. So I'm going to write negative 1x, negative 6x. And then we just start doing our basic area model for the factoring. So x times x is x squared, x times negative 6 is negative 6x, x times negative 1 is negative 1x. And now I've factored, I know the outside. So I'm going to write 0 equals to x minus 6 and x minus 1. Now remember, we learned this a long time ago. If we're going to find where the quadratic's equal to 0 and we factored into its binomials, we really just need to bring out the opposites of what is there. So I would say, well, x would be equal to 6. 6 minus 6 would give me the 0 I'm looking for. And then x equals to 1. If I put 1 in here, 1 minus 1 would also give me the 0. So the one thing that's different on this is we are going to have to actually, we've got two solutions, but we need to go ahead and graph. And if you remember, we're going to check for our extraneous. Now, an extraneous is an answer that shows up in the algebra but it's not actually a real answer. So we're going to go ahead and we are going to type in x, the square root of x plus 3. You can see I've actually already done that. And then we're going to type in x minus 3. And you can see that I've already done that. And I gave them 2 names as function names just because. Okay, so because we're looking for where they are equal, that means that we are going to look for our intersection. So let's go ahead, look at the graph. We're going to find one intersection in this case. So there we go. We've got x equals to 6 as an intersection. You can see it right there. So x equals to 6 is one of the intersections, but you'll notice that we're missing the other one. So what was the one that is missing? We are missing the intersection that is down here. Let's go ahead and scroll down. We are missing the x equals to 1. We can see that we're missing x equals to 1. And that means that x equals to 1 is our extraneous solution. Okay, because it's not on the graph or the intersection, and x equals to 6 is our actual answer that we were looking for. All right, y'all, I hope that helps you out. Feel free to go back, rewatch that video if you need help with that algebra piece. I hope you enjoyed it. Of course, solving with square roots is always a delight. Have a great day, y'all.